Hello students, welcome back to my channel Mathematics Applied. As I told you in my last video, I will be starting with application of integrals. So application of integrals is the easiest part of the whole portion for term 2, 12th mathematics. So I will start with that. What I am trying to do is I have divided this whole portion into three parts. Part 1 refers to the basic the skeleton for application of integrals. I mean, what are we going to do in that? So my third part is going to contain the actual application of integrals. Okay, the first two parts is going to carry the skeleton of the whole content. So what is that skeleton? If we know this, then we are at a safer space where we will be able to understand what the question is and we will be able to attack the question and solve it ultimately. So three parts is why three parts? Because I have divided the whole problem of understanding and then reproducing it into three parts, and then I have to conquer each and every part. I means you, okay? So actually you are going to see this, and then if you understand this, then you are going to see the problems how to it to be solved. So at the end of this three parts, you must ensure that these 4 marks are there in your pocket. Okay, so that's how I have made this video. I hope it is beneficial for you. So in the first part, I am starting with mathematical forms and the graphs of straight lines, conic sections. This is the raw material over which we are going to act upon for applying integrals. Okay, so let us understand what these raw materials are. They should have some mathematical form, and that is equations and their graphs. In problems we will be given only the equations. Sometimes it will be said that it's a line, it's an ellipse, it's a parabola, it's a circle. Sometimes it won't be said like that. So as a student, you must be able to, as an examinee, you should be able to recognize what equation that equation refers to. So mathematical form will refer to some graph. We already know that in mathematics, whatever equations we have corresponding to that equation, there will be some graph. So let's go ahead straight. So parallel to axis is one set of lines, inclined to axis is another set of lines. So parallel to axis, what are the different axes we have? X axis and y axis, isn't it? Only two axes we have. So let's draw one line where you have a line which is parallel to x axis. I draw a line parallel to x axis. This is the line parallel to x axis. Let's say it cuts at y equal to a. Over all the points on this line, you will see the y coordinate is always a, and we use that concept, that fact as the equation for the line. So y equals a is the equation. So x axis means y equal to a will be the kind of equation. Okay, y equal to a will be the kind of equation for any line which is parallel to x axis. Any line which is parallel to y axis, let's say it is cutting the x axis at b. So all the points over this line's x coordinate will be b. So we use that concept, x equals b. So we have x equals b is the equation for the line. B means it's a constant. X and y are variables. Okay, so there will be some value like x equal to 4 means it is a line which is parallel to y axis and it is cutting the x axis at 4. So it will be parallel to y axis. That is how it is going to be. So these are the two lines for two sets of lines. So it can be x equals minus, x equal to plus, y equals plus or minus some value. Okay, that is going to be the parallel to x axis and y axis. There are lines which are inclined to x axis and y axis. How are they going to be? Let's draw one line. A line which is like, let's say a line is there. Now this line cuts the x axis, let's say at a, and it cuts the y axis at b. Now from our previous classes, we know that a line which cuts the x axis and y axis at A and B are given by x by A plus y by B equals 1. This is how we write an equation, right, for a line which cuts the x-axis, and this is called intercept form. We already know that it is intercept form, isn't it? So intercept form is 1. Sometimes they will be giving equation in this form. If it is given in this form, you understand that the x intercept is A, y intercept is B. We know this. Okay? So we can quickly draw the graph, right? And if an equation is not given in this way, if it is given like this, bx plus ab, bx plus ay equal to ab, if this form is given, usually our general form of line is ax plus by plus c equal to 0. So lines will be given in this form only, and this form looks like this, right? There is a coefficient for x, there is a coefficient for y, and there is some constant. If you bring this constant this side, that becomes c. So what you have to do is, you need not convert this into this form. That's one way. You can do that. If you are capable of doing it, that's good. If you can convert this into intercept form and know the x-intercept and y-intercept and draw the line. Our objective is, from the mathematical form, you must draw the graph. That is our objective basically. Because questions are not going to carry the graphs, it is going to carry the mathematical forms. So you have to convert the mathematical forms into the graphs, isn't it? Because you ultimately have to, in application of integrals, you have to draw the graph. So your equation sometimes may be like this, or most of the times it will be like this. So how are we going to convert this into this? Either we can convert this into this by dividing the whole thing by c and minus c. We convert this into by dividing this whole thing by minus c. So we will get whatever values, x divided by minus c upon a, y divided by minus b upon a, and that will be equal to 1, isn't it? So that way we can convert it into x by a, y by b. So we will get x-intercept and y-intercept. But that is one way. And there is another way of doing it. What we can do is, we can just apply x equals, put x equals to 0 in this. Put x equal to 0. So you will get corresponding y. You will get corresponding y equals minus c by b, right? And put y equal to 0, and you get x equals minus c by a. So these are the two intercepts, x-intercept and y-intercept. So you can draw the graph. On the x-axis you take a point that is minus c by a, and you take a point on y-axis minus c by b. So these 2 points are there, and just connect these 2 points. That's it. Now this is how we draw the line. Okay. As an example, I will give you one equation. I will take one equation wherein suppose the equation is given to you like this: 3x plus 4y equals 12. If this is the equation given to you, you can divide the whole equation by 12 and get the values of x-intercept and y-intercept. Or else you put x equal to 0, and that gives you y equals 3. And put y equal to 0, y equal to 0, and you get x equals 4. So these are the two intercepts. Now just take x equals 3, x equals 4, and y equals 3, and just draw the line. So this is how you draw the line, and that's it, done. But this this calibration has to be done properly. Okay, it should be to the scale. So what I am trying to tell you in first part is, what is the raw content of that, raw materials which are there, and how to convert that. That will be in the mathematical form, that is in the form of equations. You have to convert these equations into their corresponding graphs. Now graphs should be to the scale. To the scale means roughly to the scale. Okay, you have to draw it. Only then you will be able to understand what is to be done. Okay, so let's master this first, and then we will go ahead. That's it for the inclination or incline, about straight lines. Okay, so let's go into the conic sections. Next one. So under conic sections, you have got the first one is circle. So what type of circles are we going to have? So I will draw a circle first. The simplest circle in this set of problems, there will be simple circle, simple parabola, simple ellipse. That is the standard forms. Okay, standard forms only. What are these standard forms? Let us understand that. A, if you take a circle of radius A, then this side will be minus A, this side it is going to be A, this side again it is going to be minus A. So you can just connect them, and this you can draw with your free hand, you can draw, else you can use a compass to draw this. So this is a circle, a standard circle where its center is 0, 0, okay, whose radius is A. So we give the equation for such a circle, because you know that you take an arbitrary point xy, and from this point to this point the distance is always constant. That is the logic for drawing the circle. So the distance between these 2 points is x square, x minus 0 whole square plus y minus 0 whole square. So that is x square plus y square whole root, isn't it? Root over, which is going to be equal to a. This is the fact for this circle. So what we do is we square both sides and we get the equation for the circle. So x square plus y square equal to a square. This is going to be the circle that will be given to you all the time. Okay. So how would you recognize if the given equation is a circle or not? How would you recognize that? You just first see if you have x square and y square. Both are there. Okay. First find x square and y square, both are there. And with them, this coefficient is, both of them are the same. Okay, if it is 2x square plus 2y square, then also it is a circle. So otherwise it is 1, 1. Both of them should be the same. So coefficients of x square and y square should be the same, and there should be a plus in between. There is a plus in between. Obviously, if there is minus, then it does not represent a circle. Okay. But of course, in your application of integrals content, in the raw materials, there is no such thing like x square minus y square curve is not there. So don't worry about it. It is always going to be plus. Okay. So this is the equation for standard equation for circle of radius A. So A is the radius. Okay. Please understand that. This is the circle's equation. Now let's see quickly for parabola. What are the equations? What is a parabola? How do we draw a parabola? I will draw a parabola here. So one parabola is like this. Okay. The one parabola is like this. Its mouth is open on the right side. Such a parabola is going to be written like this: 4ax. Y square equals 4ax. This is the equation for this parabola. Okay. Then y square equals minus 4ax. This is another parabola which is, by common sense we understand that it is going to be this way. Right. So open on the left side, that is minus 4ax, and then x square equals 4ay. So how that parabola is going to be? It's going to be like this. This is the third one. Okay. This is the third one. And this is the second one, this is the second one, and this is the first one. Okay. So what is the fourth one remaining? That is x square equals minus 4ay, and that curve is going to be like this. So these are the 4 different parabola in the content for application of integrals. Okay. So what is this? How would you recognize? Now you will be given this. Like for example, y square equal to 8x. You will be given this. Now how would you recognize that this represents a parabola? You will see x, the power of x is 1, the power of y is 2 here. So one is 2, the other one is 1. If that is so, then you recognize that in every case it is like that. Y, degree of y is 2, degree of x is 1. Here also the same. Here it is x degree is 2, y degree is 1. So like that, you know the other one also. If such is the equation, then you understand that that represents a parabola. So for parabola, you have all these four kinds, okay, four forms. So these are the four forms. You should be able to draw, you are expected to draw the graphs for this. How would you draw the graph? You know, you put x equals 0, you get y equals 0. This is obviously one point. This point is obviously there through which the parabola is going to pass. Now, you know, you take one more point, x equals, let's say 2. If you take x equals 2, then this is going to give you 2 8 is 16. So y equals y square equals 16. So that is y equals 4 plus or minus 4. So obviously what you can do is you take 2 here and you take 4 in this part, and you know you can draw a rough parabola that should be symmetric to the x-axis, isn't it? This line, this parabola will be symmetric to x-axis. We must understand that by our common sense. We understand that it is going to be symmetric to x-axis, and this one is going to be symmetric to again x-axis only. This is going to be symmetrical about the y-axis. This is also symmetric about the y-axis. So this is parabola. Okay. So equations are going to be like this, and you are going to draw the graph the way I told you. You can repeat the video once again and see if you have not understood certain things. You can repeat it again and again and master this part, so that you know this 4 marks, as I told you, 4 marks should be in our pocket when we come out of the examination room. Now next is ellipse. Let's talk about ellipse. Now what is an ellipse? It's just, you know, take a circle and compress it from one side. You know, press it from one side. So you have one side is going to be one, you know, one of the diameters of this. I am calling it as a diameter because a diameter is of a circle, isn't it? So if I press it from one side, it is going to be from one side it is going to be, you know, minus b and plus b. On one side it is going to be minus a and plus a. So if you connect this, you know, with roughly if you connect with a smooth curve, you will get an ellipse. Okay, we get an ellipse. So this, what is the equation, standard equation for the ellipse? What are the points? We must understand that this is the center of the ellipse, this is the vertex of the ellipse, which is going to be a comma 0, and this is minus a comma 0, and this is minus 0 comma minus b, and this is 0 comma b, because this is on the y-axis, isn't it? So these are going to be the points. You know, in every graph you should be able to recognize this. How would you recognize? Because you will be given only the equation. Now what is the equation for this curve? The equation for this curve is x square by a square plus y square by b square equals 1. Okay, this is the standard form for an ellipse. Okay, where you see that a is greater than b. So always for ellipse a is going to be greater than b. For ellipse a is going to be greater than b. So you know, in this case it is below the x-axis. This a is below the x-axis. Therefore x is the major axis. This is going to be the major axis, and this one is going to be the minor axis. This is minor. Okay, so wherever b comes, that axis is going to be minor. So now there is one more form of this ellipse. What is that form? We can draw the ellipse like this. You can draw an ellipse like this. No, your y-axis is going to be major. So in that case, your equation is going to be x square by b square plus y square by a square equal to 1. This is the second form. So in ellipse there are two forms. Again, there are two forms. One form is this, another form is this. How would you draw this equation? For example, if you take x square by 9 plus y square by 16 equals 1. If this equation is given like this, what would you understand from this? You will first convert this into the perfect square thing. You know, denominator is 3 square plus y square by 4 square. You convert this and you have the, you see this is smaller than this. That means major axis is going to be y. So if major axis is y, then what is its vertex? Vertex is going to be 0, 4. So you will draw this graph like this. You have to, for this equation, your graph is going to be 0, 4. Here 0, 4. Because 4 is your greater value. So you take 0, 4 and 0, -4. Mark it first. And then 3, 0, 3, 0 and -3, 0. Mark this and then connect this. And that gives me the ellipse. This is how you will draw the ellipse. Okay. So given the equation, we should be able to draw the equations. So this is about the mathematical forms and their equations. So I just summarize this. Lines inclined to x-axis, lines inclined to y-axis, then conic sections. So I'll just summarize it to end this video. So lines parallel to x-axis, y equals a. Lines parallel to y-axis, x equals a. Then lines inclined at one to both the axes, then it is going to be ax plus by plus c equal to 0. This will be the equation given to you. You will be using just x equals 0 and y equals 0 to find the intercepts and draw the line. Then there is circle x square plus y square equals a square, where a is the radius. If x square plus y square equal to 5 is given to you, what you do is root of 5 whole square. You do this. So radius of the circle is root 5. Okay. So that is how we draw the curve. Okay. Then you have the parabola, that is of 4 forms, 4ax, where a is the focus of the parabola. Okay. Focus. So you can refer to your 11th standard syllabus to understand that. Minus 4ax, then x square equals 4ay, x square equals minus 4ay, and these are the 4 forms of parabola. Only these curves are there in your syllabus. And then x square by a square plus y square by b square equal to 1, or x square by b square plus y square by a square equal to 1. Now these equations will not be given in this form. How would you recognize that it is a ellipse? Because your circle also looks like this, isn't it? So how would you recognize if an equation is given? If it is given in this form, you can recognize that is, obviously x square's coefficient is 1 by a square, y square's coefficient is 1 by b square. So they are different. You can understand that it is not a circle. Obviously it is going to be an ellipse, and this has to be plus. Okay, for ellipse it has to be plus, and a will always be greater than b. Wherever a is, that is going to be the major axis. Not always the equations are going to be of this form. Sometimes the equation will be like this: 16x square plus 9y square equal to 54. Okay, 54 or 144. Sorry, 144. If this equation can be like this, ellipse equation can be like this. Now what you have to do is just you have to make this 1 no. So just divide it by 144 on the right side. On the left side also you divide it by 144. You will get the values, corresponding values that are the intercepts, okay, of the x and y. So you can draw the ellipse. That's it for this video. That is part 1. I meet you in part 2. Thank you.